10th CBSE Mathematics, Chapter Surface Areas and Volumes. After watching this video, you will be able to find the volume, curved surface area and total surface area of the frustum of the cone. We have seen a paper cup, party cap, bucket. If we want to make this paper cup, then we can take a cone, cut it with a scissors parallel to the base. We get two separate parts. We remove the cone that is formed and we keep the part that is left over, and this is called as the frustum of a cone. Now these solids, the paper cup, party cap and bucket, are solids that are in the shape of a frustum of a cone. If R1 is the radius of the top of the frustum of a cone, and if R2 is the radius of the base of the frustum of a cone, if H is the height of the frustum of a cone, and L is the slant height of the frustum of a cone, then let us see the formula that we can use to find the volume, curved surface area and total surface area of the frustum of a cone. Volume of the frustum of a cone is given by the formula 1 by 3 pi h into R1 square plus R2 square plus R1 into R2. Now the curved surface area of the frustum of a cone is given by the formula pi into R1 plus R2 into L, where L is the slant height. Now the slant height can be calculated by using L is equal to square root of h square plus R1 minus R2 the whole square. Now if we have to calculate the total surface area of the frustum of a cone, then we have to first calculate the area of the top of the frustum of a cone, which will be given by pi R1 square plus the area of the base of the frustum of a cone, which will be given by pi R2 square plus the curved surface area, which is pi into R1 plus R2 into L. Let us solve some problems and understand this concept better. Let us take a real life example where we have a pastry bag in the shape of a frustum of a cone. The pastry bag is used to decorate cakes. The radii of the circular ends of the bag are 2 inches and 0.5 inches. The height of the pastry bag is 6 inches. How much icing can be filled into the pastry bag? Let us first write the data that is given to us. The radii is given as 2 inches, so let us take R1 as equal to 2 inches. So R1 is equal to 2 inches. Then we have R2 as equal to 0.5 inches. So R2 is equal to 0.5 inches. We also have been given height of the pastry bag as 6 inches. So H equal to 6 inches. Now we have to find how much icing can be filled into the pastry bag. That means we have to find the volume of the pastry bag. And because the pastry bag is in the shape of a frustum of a cone, we will write the formula for finding the volume of the frustum of a cone, which is 1 by 3 pi h into R1 square plus R2 square plus R1 R2. Now let us substitute the values. We get 1 by 3 into Let us take the value of pi as 22 by 7 multiplied by h is 6 into 2 square plus 0.5 square plus 2 into 0.5. Let us solve this. We'll get 1 by 3 into 22 by 7 into 6 into 4 plus 0.25 plus 1. 1 by 3 into 22 by 7 into 6 into 5.25. Now simplifying this, we get 22 into 2 into 0.75. If we multiply this, we will get the volume of the pastry bag. The another way of doing this is we can write 0.75 as 3 by 4. So we get 22 into 2 into 3 by 4. We can simplify this further and get the answer as 33 cubic inches. So the icing to be filled in the pastry bag is 33 cubic inches. Let us take a real life example where an open bucket is in the shape of the frustum of a cone. The radii of the circular ends of the bucket are 20 centimeter and 12 centimeter. The height of the bucket is 15 centimeters. Find the area of the metal sheet used to make the bucket. Now let us see the data that is given to us. Let us take R1 as equal to 20 centimeters, R2 as equal to 12 centimeters, height is equal to 15 centimeter. Let us mark this in our diagram. R1 is equal to 20 centimeter, R2 is equal to 12 centimeter. The height h is equal to 15 centimeter. Now we have to find the area of the metal sheet used to make the bucket. For this, we will have to calculate the curved surface area of the bucket and add it with the area of base. So the area of metal sheet is equal to curved surface area plus area of base. Now curved surface area of the bucket is pi L into R1 plus R2, area of base pi R2 square. Now here L is not given to us. Let us first calculate L. L will be given by square root of h square plus R1 minus R2 the whole square. Substituting the values, we get L as equal to square root of 15 square plus 20 minus 12 the whole square. Solving this, we get square root of 15 square plus 8 square, which is equal to square root of 225 plus 64, which is equal to square root of 289, and square root of 289 we know as 17 centimeters. So we have calculated the slant height as equal to 17 centimeters. Now let us go back to our equation to find the area of the metal sheet. So we substitute the value of pi as 3.14, L as 17 into R1 plus R2 as 20 plus 12 plus again for the value of pi 3.14 into R2 square is 12 square. Now we can solve this further. We get 3.14 into 17 into 32 plus 3.14 into 144. Let us take 3.14 common. Then we get 17 into 32 plus 144. 3.14 into 544 plus 144. 3.14 into 688, which is equal to 2160.32 centimeter square. So the area of metal sheet used to make the bucket is 2160.32 centimeter square. In this video, we have learned to find the volume, curved surface area and total surface area of the frustum of a cone.